Hello all. Welcome to my lecture 5 for this Math 241 Trigonometry with Factors class. Now today we'll cover two sections, 3.3 and 3.4. Okay, now even though seems like each of these sections are quite short, but they have importance on their own. So again, like usual, once you're done with these two sections, okay, and if you see the supplemental lecture video available, please study from those. Now, let's start with this section 3.3. Section 3.3 is the third definition of trig function. Definition 3, trig functions on unit circle. Let's start with some idea. The idea is as follows. Now, somewhere in chapter 1, recall from chapter 1, we learned that if we have a circle with radius r centered at origin, if we have circle with radius r centered at origin, then I don't really like the circle. Yep. So suppose we have circle with radius r and we have an angle in standard position, called it angle theta. Okay. Then with radius r, right? This is r comma 0. So the coordinate here, x comma y, be the coordinate on the circle, intersect with the terminal site. Now we have learned from that chapter 1 definition 2 that sine of angle theta equals to y over r. Cosine of angle theta is x over r. And tangent theta equals to y over x. And of course the secondary trig function also, right? Okay, now what happened in this third definition is now we have we will set now let the radius becomes 1. Suddenly we have some magic happen. Okay, what kind of magic? The following. So we have a unit circle. So I start with unit circle again. Oops. Let me make it big enough. I need it big. Let's say I have a unit circle, but this time my unit circle is a big circle. Okay, so this is 1, 0. Okay, and we have a terminal side. Central angle theta. Then the radius is 1, right? Now this coordinate is x comma y. Using the definition we have earlier, then sine theta equals to y over r, but our radius now is 1, right? So our sine theta basically now just y. Notice that this is only true if the radius is 1. Okay, make it short. So sine theta equals to y. Cosine theta supposed to be x over r, but the r is 1. So it simplifies, becomes x. Is that right? So if the radius is 1, cosine theta, basically x tangent theta is still y over x. Okay. Now, the third definition says the following. Suppose we have a unit circle instead. Then the coordinate on that unit circle actually represent, so this x comma y here actually represent the x is cosine theta, the y is sine theta of the central angle theta in standard position. Okay, now this is definition 3. The third definition. We call that unit circle approach, basically saying that if you have a unit circle centered at origin with radius 1, then the coordinate of the terminal site on the unit circle, this coordinate here, okay, is equal to cosine theta and sine theta for the angle theta in standard position. Okay. Now, if I kind of like write it in another way, so let's call that definition 3 now. Let x comma y be a point on unit circle. We theta as the central angle. Then sine theta equals to y, cosine theta equals to x. Okay, now that point is on the unit circle, implies this, it's on the unit circle, implies this x squared plus y squared equals to 1. Okay, now that's the third definition. Now, we may not see the importance of this unit circle yet until much later, I think in chapter 5. Then you will see how important it is. Okay, but for now, with this diagram here, it helps us to go on with the basic basic identity 4. But before that, let's do this one thing first. Okay, before that, let's do this one thing. I think this is very important. Let's take a look on that unit circle again, but this time I make it very big. I will make it very big right now because I need to fit a lot of things here. Consider this unit circle. circle again. So the coordinate here is 1, 0, right? The coordinate here is 0, 1. The coordinate here, follow me in writing, -1, 0. And this is 0, -1. Okay, now notice, remember that the coordinate actually tells us the value of sine and cosine of the angle associated to it. Okay, for example, that 1, 0, this 1, 0 here, this one here. Okay, now that 1, 0 is associated to is the terminal side, the point associated to theta equals to 0 degrees or 0 radian, right? Okay, so you see that from there we see that cosine 0 equals to 1. Remember, cosine of the angle equals to x component, right? And sine 0 is equals to 0. Okay. Let's use degree for now, but 0 degree and 0 radian are the same. Okay, now likewise, that 0, 1 is associated to 90 degrees, right? Which is pi over 2 radian. Now then, cosine 90 degrees, that's equals to 0. Sine 90 degrees equals to 1. Right? This coordinate here, that's associated to this angle, 90 degrees. Right? Okay. How about coordinate -1, 0? Let me write it here. -1, 0 is associated to 180 degrees, or in radian associated to pi. So cosine 180 degrees equals to -1. Sine 180 degrees equals to 0. Okay. You know what? Let me do this like this. I want to move this guy here so that it's easier to see. Let's make it a bit smaller. This guy here, and a bit smaller. Okay, so that's good. Now the one at the bottom here, this coordinate 0, -1 is associated to this angle, 270 degrees, right? Okay, that's 270 degrees. Or in radian, it is 3 pi over 2. So cosine 270 degrees is 0. And sine 270 degrees is -1. Okay. Notice that we get these values right away from this definition 3. As long as you know the coordinate and the angle associated to it, you basically know the value of cosine and sine of that angle from the x, which is the cosine, and the y, which is the sine. Okay, now let's go further. This time I will do angle 45 degrees. Okay, angle 45 degrees. Actually, not only this 45 degrees, not only this 45 degrees, but also all the angles with reference angle 45 degrees. You will see that it is actually, it should be in this box. It should be in this box. Okay. Notice that if the angle here is, so this angle here is 45 degrees, which is pi over 4 in radian, then the coordinate associated to it is radical 2 over 2, radical 2 over 2. That's for cosine 45 degrees, sine 45 degrees. Okay, now notice that this angle here is 300. So this is 45 degrees here, right? Now this is the reference angle for quadrant 4, 45 degrees also. Now the angle here is angle 315 degrees, 360 minus 45 degrees, right? And in radian, that will be 7 pi over 4. Now, the coordinate associated to it, take a look. Okay, we will be talking about cosine 315 degrees and sine 315 degrees, right? Now, take a look, take a look. Okay, what should the coordinate here be if they have, it has the same x here, right? The same x. So radical 2 over 2 must be equals to cosine 315, yet the y component must be opposite to the y component of 45 degrees, sine 45 degrees. Okay, now think about it. Okay, the x component must be the same, right? Because it's the same x, right? However, the y component must be opposite to sine 45 degrees. So this must be equal to the same x, radical 2 over 2, the same x with cosine 45 degrees, but the opposite of sine 45 degrees. Okay, now likewise, the angle here, the one here corresponds to 135 degrees, right? Which is 3 pi over 4. The coordinate associated to it is, that's cosine 135 degrees, sine 135 degrees. That should be, well, it must be opposite x. The x here and here should be opposite. Okay? The x are one of them positive, the other one negative, right? Okay, but the y's are the same. Okay, opposite x, but same y. So this must be negative radical 2 over 2. The y must be the same, radical 2 over 2. See? Okay, notice that 45 degrees, 135 degrees, 225 degrees, the one we will see here, 225 degrees, and 315 degrees are all angles in quadrant 1, 2, 3, 4, respectively. And all of them have the same reference angle, 45 degrees. Okay, so from once we know the reference angles, like what we learned earlier, once we know the reference angle, then the sine cosine must be the same value, the same numbers, except by plus minus. Now, What happens if we have the 30 degrees one? Suppose this is our 30 degrees. Which corresponds to pi over 6 in radian. Now we know cosine 30 degrees is radical 3 over 2. And sine 30 degrees for the y is 1/2. Right? That's cosine 30 degrees sine 30 degrees. Now, then let's extend this to quadrant 2, 3, and 4. Take a look at the magic that it does. So this point here has the same reference angle with that 30 degrees. Okay, now notice that from the picture you can tell that it has the same y, but opposite x, right? Okay, so if this is 30 degrees, then the angle here must be 150 degrees. So 150 degrees is the angle. The radian will be 5 pi over 6. Okay, then what happened to the coordinate? Well, cosine 150 degrees, comma, sine 150 degrees must be the opposite x with this. See, the same y with this, the same y with this, okay? But opposite x. If this is radical 3 over 2, then this must be negative radical 3 over 2. Okay? So this is negative radical 3 over 2, comma, the y component is the same y, it's 1/2. Okay? How about the point here? Notice that it has the same reference angle, 30 degrees, right? Because it's in this rectangle, right? Okay, now how about the angle itself? It is 180 degrees plus 30 degrees. So that is 210 degrees. In radian, it is 7 pi over 6. Notice that cosine 210 degrees, sine 210 degrees must be the opposite of the x here and opposite of the y's. Okay, so it must be negative radical 3 over 2 comma negative 1/2. If you try to see this picture here, if you try to see this picture right away, you will get confused. Okay, just look at this picture. No, you have to start from the beginning, following me in thinking and completing this picture. Okay, no way. There's no way for you to just look at this and then know what I'm doing here. No, you need to follow me since the very beginning. Okay, now this point here in quadrant 4 with the same reference angle 30 degrees. Okay, then the angle must be 330 degrees. In radian, that's 11 pi over 6. That corresponds to the same x, which is radical 3 over 2. The same x with this coordinate here. Oh, sorry, not that one. This one. The same x, but opposite y. Right? Same x, but opposite y. This is negative 1/2. Okay. That is for cosine 330 degrees and sine 330 degrees. Okay. I hope you are not overwhelmed yet, because we still have one more, the 60-degree one. 60-degree, let me use, I already use, do I have other color? No. Let me use blue then. Okay, so for 60 degrees, let's say it's here, so 60 degrees, not precise, I know. For this one here, 60 degrees corresponds to pi over 3 in radian. Then the cosine 60 degrees sine 60 degrees is 1/2, comma, radical 3 over 2. Now we know cosine 60 degrees 1/2, sine 60 degrees is radical 3 over 2. Now get the rectangle. This rectangle here will hit all the coordinates with the same reference angle. Okay, so this coordinate here have the same reference 60 degrees as reference angle. Okay. So if this is 60 degrees here, I'm talking about this. If this is 60 degrees, then this must be the supplement, 120 degrees, right? So this is 120 degrees. That corresponds in radian to 2 pi over 3. What happened to the coordinates? Then cosine 120 degrees sine 120 degrees is equal to, cosine in quadrant 2 is negative, 120 degrees, reference angle 60 degrees, so cosine 120 is negative 1/2. Okay, now notice that is the opposite x. The x that we have here is the opposite of the x we have here, right? One of them go to the right, the other one go to the left. The y component, on the other hand, is the same component to this guy, the same component to this. The y component are the same. Okay. So the y component must be radical 3 over 2. Okay. Let's go on. This guy here, the reference angle 60 degrees in quadrant 3. So the angle must be 180 degrees plus 60, that's 240 degrees. That corresponds to 4 pi over 3 in radian. And the coordinates will be cosine 240 degrees, sine 240 degrees. Now you can tell the coordinates here in quadrant 3 must be negative, negative, right? So it must be negative something, it's quadrant 3, right? But what number? Cosine 240 degrees is negative in quadrant 3, reference angle 60 degrees. Cosine 60 degrees is 1/2. Sine 60 degrees is radical 3 over 2. Now we just adjust the plus minus sign. Lastly, reference angle 60 degrees in quadrant 4. (60 degrees in quadrant 4, then the angle must be 300 degrees, right? In radian, it must be 5 pi over 3. The coordinates is cosine 300 degrees, sine 300 degrees, which is cosine in quadrant 4 is positive. Reference angle 60 degrees, cosine 60 degrees is 1/2. Sine in quadrant 4 is negative. You can tell the y component in quadrant 4 should be negative, right? Okay. Reference angle 60 degrees, so sine 60 degrees is radical 3/2. Okay, that's a big picture, huh? Let's see this picture in full. I hope we can make it. It's more. You see so much details I put in there. Okay, follow me in writing from the very beginning. Okay, now I will give you this file in the discussion board. Okay, try to do it on your own. Okay, let me insert that here. Give me a second. Oops, I'm sorry. It doesn't work. Second. Second. Okay, I insert this file on this note here. I will post the file as the unit circle trick on your discussion board. Let me show you where it is. Set our discussion board here. On our discussion board, I put it, let's say I put it circle. Okay, now try to print it out and then fill it up. Okay, print it out and fill it up. It's good for you. Practice. You want to visualize that? This is how you visualize that. Okay. This is how you visualize it. So let's say how I want you to fill this up. How I want you to fill it up. Let me start with here. Let's start with this one. This is 0 degrees. Okay, in radian, this is 0 radian. The coordinate is 1,0. Okay, now this one here is 30 degrees. In radian, that's pi/6. The coordinate is radical 3/2, 1/2. This one here is 45 degrees. Okay, in radian, that's pi/4. The coordinate associated to that on the unit circle is radical 2/2, radical 2/2. This one here is 60 degrees. In radian, that's pi/3. The coordinate is 1/2, radical 3/2. As you can see, all sine, cosine, tangent are positive. Okay, at 90 degrees, the radian is pi/2. The coordinate associated to it is 0,1. Okay, this one here is 120 degrees. The radian is 2 pi/3. The coordinate, notice that the coordinate here must have the same y with this. So the y must be radical 3/2. Okay, radical 3 over 2. Now the x must be negative. Okay, it is the same x here, but because the x is in quadrant 2, then it must have the negative sign. Okay, the y are the same though. It's the same height, right? The same y component. Okay, now I want you to complete this circle this way. Okay, let me complete this, but then make sure you repeat the same procedure yourself. And don't feel bad to do it like 3 times, 4 times. Okay, in the end, it's not how many times you do it. It's about how well you memorize this. Okay, the radian of 135 degrees, 3 pi over 4. Okay, this is negative radical 2 over 2, radical 2 over 2, 150 degrees. The radian is 5 pi over 6. The coordinate is negative radical 3 over 2, comma 1/2. 180 degrees, the radian is pi, the coordinate is negative 1, comma 0. Okay, and in quadrant 3, reference angle 30 degrees. So it must be 210 degrees, right? And then the radian is 7 pi over 6. Yeah, try to memorize the special angles in radian also. Okay, and the coordinate is negative radical 3 over 2, negative 1/2. Now take a look. How do I get that number? I actually steal it from here because this point has the same x with this. So the x must be the same, right? And because x must be the same and both of them in unit circle, then the y must be the opposite, right? Okay. Let me go on. And then 225 degrees reference, that's for 5 pi over 4. The coordinates is negative radical 2 over 2, negative radical 2 over 2. 240 degrees. Okay, that is 4 pi over 3. The coordinate is negative 1/2, negative radical 3 over 2. 270 degrees. The radian is 3 pi over 2. The coordinate is 0,1. And then 300 degrees, right? 5 pi over 3. The coordinate is 1/2, comma, radical 3 over 2. I'm sorry, negative radical 3 over 2. 315 degrees. The radian is 7 pi over 4. Okay, the coordinate is radical 2 over 2, comma, negative radical 2 over 2. And finally, 330 degrees. The radian is 11 pi over 6. The coordinate is radical 3 over 2. Okay, in quadrant 2, the one positive is sine, the one negative are cosine and tangent. Sine is positive, cosine tangent are negative. In quadrant 3, the one positive is tangent. Okay, sine and cosine are negative. In quadrant 4, cosine is positive, sine and tangents are negative. Okay. Please see how I did this unit circle. Okay, and then print out your own file, try to do it on your own. Okay, now, furthermore, once you are done with that, make sure you memorize this. Memorize this. Okay. Memorize. I purposely write it this way so that you know it doesn't take only 1 or 2 minutes to do this. To memorize this, especially if this is the first time for you, then it will take some time for you to memorize this. Okay, yeah, you do your own, you print it out, you fill it up. Okay, make sure you match with what I have here, and make it a couple times and post it maybe next to your bed, in your bedroom, on your desk, maybe next to your dashboard when you drive, right? And you hit the traffic and you look at this, try to memorize it, internalize that. Okay, it does take some time. Well, no, I don't promise you easy way out. Okay, the reason it is very rewarding is because you then see how useful what you learn here. Okay, now let me go on. Also, from what we learn from here, we can now prove basic identity for the one at negative angles easily. It is by observing the following. Suppose we have, again, a unit circle. Suppose we have a unit circle. Okay. Notice if I have the angle theta here, if I have angle theta here, radius 1, so the coordinate here must be cosine theta, sine theta, right? Now, likewise, if I go with negative angle, which means I go clockwise, okay, the same reference angle, but this time is negative theta instead. So the coordinate here must be cosine of negative theta. And the y component is sine of negative theta. Now notice that the position, the x component of this coordinate must be the same to the x component of this coordinate, right? The x component must be the same. So we can conclude, first conclusion, cosine negative theta must be the same to cosine theta, right? The x component must be the same. On the other hand, the y component of this coordinate is the opposite of the y component of this coordinate here. Must be opposite, one of them positive and the other one negative. So from there, we conclude that sine of negative theta must be the opposite of sine theta. Okay, that is, now from here we go on seeing that tangent negative theta equals to negative tangent theta. Let me just prove it right away. The proof is actually as simple as this. Now we know that we prove from left to right. Okay, left hand side we have tangent negative theta, which by definition is by ratio, that's sine negative theta over cosine negative theta. But according to our point 1 and point 2 above, sine negative theta is negative sine theta, while cosine negative theta is simply cosine theta. And therefore we get this is negative tangent theta, which is our right hand side. Okay, now with the same ideas, you will see later on that, for example, secant negative theta is secant theta. Cosecant negative theta is negative cosecant theta, and tangent negative theta, cotangent negative theta is equals to negative cotangent theta. Okay. Now, this is basically what we have in B14, the trig functions of negative angles. Okay, some little note to add. Note a function fx is an even function, is called an even function if the value at negative x is the same to the value of the function at x. Okay, as you can see, for example, above, cosine theta and secant theta are even function. Okay. Similarly, a function is called odd function. You don't really need this definition now, even odd functions thingy. But when you go to pre-calculus later on, then we will talk about this a lot. It has something to do with the symmetry of the function, which we will see also in this class somewhere in chapter 4. Okay, f of the value of the function at negative x equals to the opposite of the value of function at x. Now, for example, sine theta, tangent theta, cosecant theta, and cotangent theta are all functions. Okay. Now let's do some examples. So we do theory so far, right? Let's do some example. How do we use the fact of that basic identity 4 to answer some questions like this? For example, what is the value of sine of negative 60 degrees? Oh, sine is an odd function. So sine negative is negative sine. And sine 60 degrees is radical 3 over 2. So negative 60 degrees, negative sine 60 degrees is negative radical 3 over 2. Okay, part B. How about cosine of negative 2 pi over 3? Now, cosine is an even function. So cosine negative is cosine positive. Okay, but 2 pi over 3, notice that 2 pi over 3 is in quadrant 2, right? Maybe I write that as a note. 2 pi over 3 is in quadrant 2. Try to picture that. It's more than pi over 2, but less than pi, right? So it's somewhere here. Now, knowing that cosine is 2 pi over 3 is in quadrant 2, then it must be negative cosine of the reference angle, which is negative 1/2. Okay, part C. How about cosecant of negative 225 degrees? Oh, cosecant, I don't know yet. I know that's a reciprocal sign. So 1 over sine of negative 225 degrees. Now, then from there, sine is an odd function. So sine negative is negative sine. Okay. And then 225 degrees is in quadrant 4. I'm sorry, quadrant 3. 45 degrees. The reference angle is 45 degrees. Okay, so in quadrant 3, it's negative. Let me make sure that you know what I'm doing here. So I'm replacing this one in yellow by negative sine of the reference angle. Okay. Negative and negative becomes positive. We just have sine 45 degrees, which is radical 2 over 2, which simplifies to be 2 over radical 2, which is simply radical 2. In fact, I actually prefer to write it this way. The sine 45 degrees is 1 over radical 2. And the reciprocal of that, therefore, right away is simply radical. Okay. These are the 3 questions that we can use directly from here. We can do more problems, of course. Let's take a look, for example, on number 17 in our textbook. I think this is important. Number 17. Let the sine theta equals to 1/2. Now notice that it doesn't say theta is in quadrant 1. It doesn't say that theta is an acute angle. Okay, so think about in that unit circle, when does the y, which is sine theta, to be 1/2? There are 2 angles correspond to that, right? Okay, take a look on the reference angle first. Okay, solution. So find theta. Solution. Take a look on the reference angle first. Sine theta equals to 1/2. So sine theta hat must be 1/2. And therefore, what is the angle? What is the acute angle such that sine of that acute angle is 1/2? We know that's 30 degrees, right? Okay. Now then, think of the angle with reference angle 30 degrees where sine is positive. Sine is positive in quadrant 1 and quadrant 2. Okay, so in quadrant 1, theta must be just the reference angle equals to 30 degrees, right? Okay, but in quadrant 2, the angle is 180 degrees minus that reference angle. Okay, these are the answers. In other words, sine 30 degrees equals to 1/2, but sine 150 degrees also 1/2. Now, if you use calculator and just apply sine inverse of 1/2, you will get sine 30 degrees, or you will get 30 degrees only. Okay, that's why don't use sine inverse directly. And remember, if you use sine inverse, that will give you an acute angle only. Okay, while we know that there are 2 values, 2 angles that give you sine theta equals to 1/2 in this unit circle. Okay, so look at the reference angle first, and then think about it. Oh, you know what? Sine is positive in quadrant 1 and quadrant 2. Okay, so number 21. Number 21. Similar question. Tangent theta equals to negative radical 3. Okay. Find theta. Solution. Look at the reference angle first. If tangent theta equals to negative radical 3, it means theta must be in quadrant 2 or quadrant 4, right? Let me write that. Theta is in quadrant 1 or quadrant 2 for number 17. Number 21, theta must be in quadrant 2 and quadrant 4. Now, get the reference angle first. So tangent theta hat equals to radical 3. Theta hat must be 60 degrees. That's the reference angle. Okay, now think about the angle in quadrant 2. What is the theta such that the reference angle is 60 degrees? That's 180 degrees minus 60 degrees. That's 120 degrees. In quadrant 4, the angle that has reference angle 60 degrees is 360 degrees minus 60. It's 300 degrees. Okay, try to picture it. In quadrant 2, reference angle 60 degrees, this one, right? Okay, so what will this be? That's 120 degrees. Now, on the other hand, if the angle is in quadrant 4, what is the angle in quadrant 4 such that the reference angle is 60 degrees? Then this part here must be 300 degrees. Okay, try to picture it. Now that's for that 3.3. The suggested homework from here, suggested homework for section 3.3 is number 9 to 21, 39 to 41, and 55 to 59. Okay, that's for 3.4. Now we go on to the new section 3.4. You will see that this section does not require you to be really good in the earlier sections. No, you need to know those, okay, but you don't need to be really good. You can think of this as kind of like a side lesson to equip you further into this trigonometry, but does not require too much skill at this point to learn. Okay, I think you can think of this 3.4 as extra lesson, but at the same time, it's like a little break for you, okay, because how to say that, it's not too hard, okay, it is not too hard, but you need to be disciplined. Okay, in this section, we will learn two topics. The first one is arc length, and the second one is sector area. Okay, the first part, arc length. Suppose we have a circle, okay, with radius r, okay, and angle theta. The central angle is theta. Now, the arc length, which refers to this here, the length of the arc subtended by that angle theta. The length of the arc, part of that circle, the length of part of that circle that is cut off by that central angle theta. We call that S. Now, we have learned in the past that theta is equal to S over R when theta is in radian. That's actually the definition of angle in radian, right? Now, believe it or not, actually from there, we go ahead, multiply both sides by R, we get the arc length S is equal to theta times the radius. Again, the theta has to be in radian. Okay, maybe I write it explicitly. Note theta has to be in radian. Okay, let's take a look on example 1. I hope that's simple enough. Example 1, we have given the length of the arc cut by central angle of 2 radians. So we have a circle with central angle theta 2 radian. okay, with radius 4.3 inches. So the theta is 2 radian. The radius is 4.3 inches. So how about the arc length? What is the length of this arc here? Then the arc length equals to theta times r, which is 2 times 4.3, that is 8.6 inches. Just like that. That's simple. Okay. Then what happens if the angle is actually in degrees, Thomas? Well, if the angle is in degree, then convert that to radian first. Another example. Let's say we have a pizza. The radius of that pizza, let's say, is 5 inches. Okay, and the central angle here is, let's say, 30 degrees. So what is the length of this crust part? Okay. What is the length of that? Well, then the way we compute that, well, theta equals to 30 degrees, which is equal to pi over 6 in radian. Now, 30 degrees happens to be a special angle, and we happen to know what the angle is in radian. Okay, now the radius is 5 inches, so the arc length will be pi over 6 times 5 inches. That's 5 pi over 6 inches. That's it. Okay, and you can just leave it like that. You can use calculator to use to replace that pi by 3.14 something, and then multiply by 5 divided by 6. That will give you some ugly decimal. Okay, that's okay. But in this class and pre-calculus and calculus, we can just leave the answer in this exact form, 5 pi over 6. Okay, now that's for the arc length. Let's go on to the second part, sector area. What is the sector? What is a sector to start with? A sector is actually part of the, oops, sorry. I want to say this, let's say this is the radius here, and you have another radius here. Okay, now the sector is this part here. This is a sector. The one that looks like a pizza, of course, that if the angle is big enough, then it doesn't look like that slice of pizza anymore. Okay, but the sector is that triangle like, not really a triangle, but almost like a triangle like region. Okay, now the area, sector area, is proportional to its central angle. The larger the central angle, then the larger the area. Okay, therefore, sector area, let me denote it by A for area and then that pizza slice. Okay, the ratio of that sector area to the area of the circle must be equal to the ratio of the central angle theta, this is central angle theta, to the angle formed by a full circle. In radian, that's 2 pi. Okay. Consequently, the area of a sector, the sector area, equals to theta over 2 pi times the area of the circle. Now, area of the circle is pi r squared. Notice that the pi then cancels. Therefore, we get area of the sector area. Therefore, is 1/2 times theta r squared. Okay. Now, so if we look back to our, for example, our example 1 here, okay, going back to example 1, going back to our example 1, we have that circle, okay, with radius 4.3 inches, and the angle is 2 radian. So what is the area of this sector here? How big is this yellow shaded region? The area is 1/2 times the central angle in radian 2 times radius squared. Okay, that will be basically 4.3 square inches. So 18.49 square inches. In our example 2, we have that pizza. Do you remember that pizza? Okay. The central angle is 30 degrees. The radius is 5 inches. Okay, then how much pizza? What is the area of the pizza you just ate? What is the area? Well, the theta is 30 degrees, but don't compute from degrees. You need to convert that to radian first. Okay, then the sector area will be 1/2 times the angle pi over 6 times the radius squared. This is 25 pi over 12 square inches. Okay. Now, your suggested homework from here will be, so this one is very short, huh? So suggested homework from here. Of course, you will see once you do the suggested homework, you exercise some of them, you will start seeing some problems that I don't cover here, but I basically cover everything you need. Well, of course, you need to put some thinking into it. Okay, that's for this lecture 5.